assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right. So this question asks us a little bit about electron affinity. And they don't actually say electron affinity in the question, but they abbreviate it using the symbol big E with the subscript of EA. So just realize that anytime you see that abbreviation, they're really just talking about electron affinity. Now, anytime you see kind of a big term like this, it's important that you define it before proceeding to work the problem. So electron affinity is the energy change that takes place anytime you try to add an electron to an atom, all right? And so I'll just kind of pencil in the phrase there, adding an electron, because that's what we're trying to do. Then what they do in the problem is give us a periodic table where they've located 3 different elements that are all on the 4th period. They have potassium at the far left, then germanium, and finally krypton at the far right. And so in general, we know that as we go across the periodic table, the electron affinity tends to increase. The atoms are gaining more protons. They tend to have stronger nuclei that are better at attracting the new electrons that we're trying to add. So if we were looking at it just from this general trend perspective, we might say that krypton has the best electron affinity, while potassium has the worst. However, they've kind of thrown a trick in here just to see if we were being careful. So what makes krypton special is that he is located in group 18, which is the noble gas group, all right? Now, if we take a look at its electron configuration, what we'll find is that it has a completely full valence shell of 8 electrons. And we sometimes call that having a full octet. And in an atom's world, having that full 8 outer electrons is fantastic. That's great, and that helps them be very stable, all right? So typically, the noble gases are very content with their 8, and they neither want to add nor lose electrons, all right? Because what would happen, if we tried to add one more electron, is it would have to go into a brand new energy level, the 5th energy level in the s orbital, all right? And that would add, a lot of work to kind of make that happen. So it would not be very favorable to give krypton an extra electron. And typically, noble gases are thought of as having an electron affinity of 0 because they're really not interested in attracting any new electrons, all right? So with that taken into consideration, krypton would actually have the least favorable electron affinity. Then we could go back to following our general trend from there. Germanium would then be furthest to the right and would have the most favorable electron affinity. And there you go.